Hello, grade 9 students. In this video, I'm going to solve with you the worksheet 2A in our lesson square roots that I sent last week. Number one, simplify the following square roots. In this exercise, we're going to apply the rule that radical a squared, where a is positive, radical a squared is equal to a. And as I said, a negative radicand does not exist. Now I have radical 7 squared. To simplify radical 7 squared, since I have inside a square, the square cancels the radical, it comes out at 7. Radical 15 squared, also the squared cancels the radical, the answer is 15. Radical 9 squared, the squared cancels the radical, it comes out as 9, so the root is 9. Radical 21 squared, the squared inside the radical cancels the radical, so the root is 21. Now radical 13 squared. Now 13 is written between parentheses. It has no effect. So also the squared cancels the radical, and my answer is 13. Radical 4, all of it squared. Sorry. So the squared cancels the radical, so my root is 4. Radical 17, all of it squared. Here, as if I have radical 17 times radical 17, so the squared cancels the radical, and my answer is 17. Radical 10 squared, it's the same. The square cancels the radical, and the answer is 10. Radical minus 8, all of it squared. Now, inside the radical, minus 8, all of it squared, this is considered a negative base. When I have a negative base, since I have parentheses and the exponent is even, the negative base becomes positive, and the squared cancels the radical, so my answer is 8. This is the same example, a negative base, it becomes positive since we have square inside. The square cancels the radical, and it comes out as a 3. Radical negative 14 square, it's the same. The negative becomes positive, the squared cancels the radical, and it comes out as 14. Now radical 5 square, it's the same as the one here I have up in the line number 2. The squared cancels the radical, it comes out as 5. Radical 19 squared, also the squared cancels the radical, and it comes out as 19. Now I have minus radical 5 squared. Here the minus is outside the radical, so it stays outside, and the squared cancels the radical, it comes out as 5. Minus radical 23 squared, also the minus has nothing to do with the radical, so it stays outside. The squared cancels the radical, and it comes out as 23. Minus radical minus 2, all of it squared. The minus outside stays outside. I write it as it is. This is a negative base. It becomes positive since I have an even exponent, and the squared cancels the radical. It comes out as 2. The same example, minus radical minus 13, all of it squared. The squared I have outside stays as it is. The negative becomes positive since I have a negative exponent. The squared cancels the radical, and it comes out as 13. Now let's look carefully at this exercise, at this example now. Radical minus 11 squared. Is minus 11 squared here considered as a negative base? No, this is not a negative base since the square is only for the 11. So here the base is 11 minus, so I will have inside the radical, I will have a negative number. 11 squared is 121. So inside I will have minus 121. And we have a rule that says a negative base does not exist. So since we have a negative radicand, so this negative radicand does not exist. The same example, radical minus 34 squared. So there is a big difference between this writing and this writing. This is, since I have parentheses, it's considered all as a base with the minus. Here, the square, the base is 34. The square has nothing to do with the minus, so I will have a negative radicand, and a negative radicand does not exist. Radical negative 4. Negative 4 is a negative radicand, also it does not exist. Now I have radical 9. 9 is not square, but is 9 a perfect square? Can we write it as a number square? Yes. 9 is written as a 3 square, so I will have radical 3 square. The square cancels the radical, and the root is a 3. Radical 49, 49 can be written as a perfect square. It's written radical 7 square. The square cancels the radical, so the root is 7. These are the root is 7. Radical 81, it's written as radical 9 square as a perfect square, and it comes out as 9. Radical 121, 121 is written as a perfect square. The perfect square, I gave you these perfect squares in the lecture, so please memorize them until 12 square, which is 144, and it comes out as 11. Radical 36, 36 can be written as 6 squared, so the answer is 6. Now I have radical 60. 60, can we write it as a perfect squared? No. Any number that cannot be written as a perfect squared, we should make the prime factorization of this number. So I decompose 60 into prime factors. Here the numbers I have on the right side of the line all should be prime. So here I should not see 4 or 6 or 9 or 10 or whatever. I should only have a prime numbers, which are 2, 3, 5, 7, 11, 13, etc. Now, what are the prime factors of 60? I write 2 times 2, which is 2 squared, times 3 times 5. Now, these prime factors, I replace them inside the radical. So I will write radical 2 squared times 3 times 5. Now, which of these numbers comes outside the radical? Only 2 squared. Since 3 has no squared on it, it stays inside the radical, and 5 stays inside the radical. 2 squared comes out as 2. So I will write 2 radical 3 times 5. And now I calculate what I have inside the radical. 3 times 5 is 15. So my answer is 2 radical 15. The same thing happens with 72. I decompose 72 into prime factors, and I replace the prime factors inside the radical. Here, 2 squared comes out as 2, and 3 squared comes out as 3. Since I have two numbers outside, I multiply them. So I will have 2 times 3, and this 2, since it has no squared on it, it stays inside the radical. So 2 times 3 is 6. So my answer is 6 radical 2. I have more examples. Radical 80, I decompose radical 80 into prime factors. Look here, I don't write 2 to the power 4. I take each 2's together. 2 times 2 is 2 squared. 2 times 2 is 2 squared. So I will write my prime factors in this way. I need to have an exponent 2. Now I replace these prime factors inside the radical. 2 squared comes out as 2, and this 2 squared comes out as 2. So outside I have 2 times 2 radical 5. 2 times 2 is 4 radical 5. Now I have 450. Also, I decompose 450 into prime factors. So I will have 2 times 3 2 times, which is the 3 squared, times 5 squared. So these are the prime factors of 450. I replace them inside the radical. 3 squared comes out as a 3 times 5, and this 2 keeps inside. So 3 times 5 is 15 radical 2. Now I should write the following radicals in the form of A radical B. I have radical 2. 2 is a prime number. It cannot be simplified. It cannot be written as a perfect square, so I leave it as it is. Always in front of the radical, I might have a number here. This number is called the coefficient. So A is the coefficient and B is the radicand. So what is A here? Since I have no number here, the only number that I can write it and I can leave it, not write it, is 1. So A is equal to 1 and B is equal to 2. Radical 8, 8 cannot be written as a perfect square. It's not prime, so I make the prime factorization of 8, and I replace the prime factors of 8 inside the radical. So 2 squared comes out as 2, so my answer is 2 radical 2. So I have written it in this way. What's A? It's 2. What's B? The radicand? It's 2. So A is equal to 2 and B is equal to 2. Now I have radical 75. I also do the prime factorization of 75, which is radical 3 times. This is not 2 square, of course. Let me correct it. This is a typing mistake. So this should be 3 times 5 squared. Of course, this is wrong. If you do the prime factorization, this should be 5. So what comes outside the radical? Of course, what comes outside the radical is 5 squared, which comes out as 5. So I will have 5 outside. Let me correct it also here. So this should be 5 radical 2 because 5 comes outside. So the answer is 5 radical 2. So what's A? Of course, I will close it. Then I will correct it again. So what's A here? The coefficient is 5. So A is 5 and B is a 3. Also, I will correct it for you. So A is 5 and B is 3. Let me continue now. Radical 200, I also decompose 200 into prime factors. These are the prime factors of 200. 2 squared comes outside as 2 and 5 squared comes out as 5, so it will be 10 radical 2. I will continue now. So A is 10 and B is 2. Radical 5, 7 to the power 5. Now 7 to the power 5, here I have to make the exponent 5 as 2's. So how many 2 do I have in the 5? I can write it in this way. It's 7 squared times 7 squared times 7. Since 2 plus 2 is 4 and 1 is 5, so it gives me 5. So I should decompose the exponent into 2's, okay? 7 comes out as 7, so it is 49 radical 7. Let me erase these numbers I have written here. The eraser, let me take the eraser and I will erase these numbers. Okay, let me continue. Radical 3 to the power 7. I should write 7 as 2's, the exponent 2. So what is 7? It's 2 plus 2 plus 2 plus 1. So I write it like this. So my answer is 27 radical 3. A is equal to 27 and B is equal to 3. Now here 5 square is written as a square. So 5 square comes out as 5. So my answer is 5 radical 11. Now 3 to the power 4. 4 is not square. I should make it square. So I make it 3 square times 3 square times 7. So it is 9 radical 7. A is 9 and B is 7. 2 times 10 to the power 6. 2 has no exponent. I leave it as it is since it is prime. 10 to the power 6, I write it 10 squared times 10 squared times 10 squared. So I decompose again the exponent into power 2. So I write it in this way. So my answer is, of course, this is not 30 because I'm solving many worksheets. Let me correct this. Of course, this is 1,000. 1,000 radical 2. 1,000 radical 2. The answer is 1,000 radical 2. Now I will continue 2 to the power 4. I write it 2 squared times 2 squared. Let me continue. 2 squared times 2 squared times 3. So it is 4 radical 3. So A is equal to 4 and B is equal to 3. Okay. Now let's calculate. I talked in my lecture how we add and subtract radicals. There is a very important rule. Whenever you have radicals and between these radicals you have plus or minus, the rule says, I look inside the radicand. I check if I have same radicands because I can only add or subtract like or similar radicands that have the same radicand. I add or subtract the coefficients. So 6 radical 3 plus 2 radical 3, I have the same radicand. 6 plus 2 is 8, so it's 8 radical 3. So my answer is 8 radical 3. 3 radical 5 plus radical 5. I have same radicand, so I can add. The coefficient is a 3. I have no coefficient. As I said, it's 1. So 3 plus 1, it's 4 radical 5. I have same radicands, radical 11. 2 plus 4 is 6, plus 1 is 7, so it's 7 radical 11. 11 radical 6 minus 4 radical 6. 11 minus 4 is 7 radical 6. 2 radical 7 minus 9 radical 7, I have same radicands, so 2 minus 9 is minus 7 radical 7. Minus 5 radical 2 minus 7 radical 2, I have same radicands. Negative and negative, it's minus 12 radical 2. Minus radical 10 minus 8 radical 10, I have same radicands. Minus 1 minus 8 is minus 9 radical 10. Minus 7 radical 13 plus 12 radical 13, it's 5 radical 13. I can add or subtract. Now here I have 2 with radical 15, I can do their answer together, and the other 2 with radical 13, so I do their answers together. 14 minus 5, it's 9 radical 15, and so I do 14 radical 5 with minus 5 radical 15. 14 minus 5, it's 9 radical 15. Minus a 3 radical 13 and minus 6 radical 13, I do their answers together since I have same radicals. So minus a 3 minus 6, it's minus 9 radical 13. 3 plus 2 radical 7. 3 is a number, and here I have a radical. I can never add a number with a radical. So please don't write 5 radical 7. This is wrong. Since I have different number and radicals, these are different, so their answer stays as it is, never added. 5 radical 3 minus 9, always. I cannot subtract a radical and a number since they are different, so they stay as they are. Also, I cannot add 2 different radicands since they are different, their answer stays as it is. I cannot subtract 2 different radicands, so their answer stays as it is. Here I have radical 10, radical 3, radical 10. So I can do 3 radical 10 and minus 8 radical 10, which is minus 5 radical 10, and I keep minus 6 radical 3 as it is. We should decompose the radicands into prime factors, then calculate. If you look at this expression, you have radical 3, radical 75, radical 27, and radical 48. These are different radicands. I can never add or subtract them. To be able to calculate the answer of this expression, all my radicands should be the same. 3 is prime, so I cannot do it the prime factorization. 75 cannot be written as a perfect square, so I should make the prime factorization of 75 and replace them. Do the prime factorization of 27 and do the prime factorization of 48. So this is the prime factorization of 75. This is the prime factorization of 27, and this is the prime factorization is 48. Now I replace these prime factors. I leave 4 radical 3 as it is. So I will replace 4 radical 3, I leave it. I replace radical 75, I replace radical 27, and minus 2, I replace radical 48. This stays as it is. Here, 5 squared comes out as 5, and I keep 3 inside, radical 3. 3 squared comes out as 3, and I keep radical 3. 2 and 2 comes out as 4, and I multiply with the 2 outside, so it becomes 8 radical 3. This is the answer. Now, if you look at this sentence, I have the same radicands. Since I have the same radicands, I can add or subtract the coefficients. 7 minus 5 is minus 1, plus 3 is 2, minus 8, it is minus 6 radical 3. Here, 2 radical 2, of course, 2 is prime. I do not do anything with this. I do the prime factorization of 8 and the prime factorization of 50. This is the prime factorization of 8. This is the prime factorization of 50. I replace the prime factors inside the radicals. Now I simplify the radicals. If you look at this sentence, I have the same radicands. So 2 minus 10 is minus 8 plus 5. The answer is minus 3 radical 2. I still have 2 more examples for you to solve in the same way. I do the prime factorization for non-prime numbers. I replace them. And after that, I simplify and calculate. These examples are so easy. Please practice them and calculate your answers. This was the solution of this week. Please correct your mistakes, and if you have any question regarding these exercises, contact me directly. Thank you.